because question 2 is weird.
Hey, everybody.
Hello.
No,
Howdy.
Okay. All right. I want to hear people's thoughts on this particular change. 1 second. Do I sound better now or now? Can you guys hear me?
Yeah.
Yes.
I didn't hear a change.
Yeah, I didn't hear a
Uh-oh.
change at all either.
Uh.
It sounded identical.
How about
Do I sound better now? Can you hear me now?
Worse.
Yeah.
Yeah, that's
Worse.
worse.
I think
Yeah, I think it's worse, yeah. It's more background noise.
More background noise. Interesting.
I think
How
the
about now?
quality is better.
I got a new microphone.
Oh, that's good.
Well, now it's in my shot, though. Hello. Anyway. How does anyone do this? Just move it out of the way? That doesn't make sense.
Maybe you put it below
Hello?
the shot. I don't know.
Ooh. See, this is why they pay you the big bucks. Okay, can you hear me now?
Yep.
Yeah.
How is the sound? Is it okay?
Yeah, I think it's good.
Cool. So, Christopher, I heard you saying that question 2 was strange? You're muted. Unmute. Nope.
It doesn't have the, cooperate and defect, or should you just assume it's the same as the video? Or just is it not needed?
If it's a bad question, I can't even remember.
Give a single iteration of each player only winning their own gains. What is the expected result? But then you throw in, the answer is not immediately obvious. Follow the reason in the video carefully.
Yeah.
And in the video,
it's different numbers.
It is different numbers, and they're different boxes.
Yeah.
And there's no, according to the video, the reasoning in the video, that option's not even there. For what I can see, I don't know.
So, I don't know if this is going to give it away.
Because here, don't you give it away. I watched the video, that section like 3 times now, and it's if on a known amount of interactions, both people will choose their own benefit first.
Yep.
But there's I don't see anybody interested in there. Shouldn't there be 5 losses? Yeah, that's what I got, but I can't correlate which box goes with that reasoning.
Can you at least eliminate 2 of the boxes? Because this is a symmetrical setup. So presumably,
I would imagine you would eliminate the lost boxes where they both lose.
Maybe.
Curses. Oh, that brings me to my next question. The thoughts on tap extra credit, since I bomb questions like this all the time and I want to bump it up my grade with the because
no worries.
I went.
Thought on So there should be, I set up a redirect, but I always forget what it is. Thought on tap, October 2020. So there's one coming up that's going to be November 12th, but there's also the recording of the previous. Oh, I should just. You know what? I'm just going to paste it on the chat.
But how do you? How are you going to go about assigning? If you because I was there already.
Oh, you were.
Yeah.
Oh well, then fuck it. Just just write something like pick pick an argument that somebody gave or a position that somebody developed, and just explain it in like a quick couple of paragraph or two. Basically, just evidence that you were there and paying attention. Nothing fancy. Okay. My hair is ridiculous. Why do I always check my hair after I get on?
Carlos,
Yeah.
quick question about that. So with the lectures,
want to
it's
hear?
only the designate. You can't hear me?
Yeah. Sorry.
Oh,
No, go ahead.
it's on. So for the extra credits, only based on certain designated lectures, or just anything that has to do with philosophy.
Anything that has to do with philosophy counts, as long as has come out within like the relevant time span, right? So like if you go on YouTube and find like a channel that's a philosophy channel, cognitive science, if it's related, in fact, anything cognitive science, a lot of psychology is going to be related to this.
And
Just-
does it have to be videos, or can it be like papers, articles?
Yeah, papers count,
Yeah.
articles count. Yeah, cool.
And it's 1 credit per paper.
Yeah. And there should be an extra credits section of Canvas. I think it might be under, damn it, every time I set up a class, I do it differently. It's either under the final exam section or under it's usually under attendance, but there's no attendance here. I don't know. It should be.
I remember seeing one. I don't know if it was like in the syllabus or in the modules, but it was just empty. It said that it was for you to put grades in there.
It should be worth, so it's going to be worth 0 points. That's the way it gets to count as extra credit. And I can put grades above 0, and then that way it gets to count for you guys as extra credit. Does that make sense?
Okay.
Yeah. So, you guys want to see a bunch of videos of animals doing fun things? Let's do it. I'm excited. I'm so excited to show you all some slime. It's going to be the best. Everybody loves slime, right? So let me change the audio so that you guys can hear it. Well, this one doesn't have audio. This is just literally slime. This is a slime mold. It is a single-celled creature that is going to find its way around a maze. It's really creepy. But eventually, it figures it out. Ugh. So when I say single cell, it's weird because you guys think of a single cell, you usually think about it as a free-floating creature. These are all a bunch of cells that can choose to get together or separate. And once it figures out its path, then things start moving quickly. It's so great. Like when it starts off right here. And then it spreads eventually, making the full connection to the end. This is one of those instances where I think that it's just supposed to be an example where something that can have apparently complex behavior without ever being intelligent. Okay, so this is the baseline. This is the counter example. Whenever you see complex behavior, a lot of people will be like, yeah, but cellular slime molds can run mazes. And you think, oh, well, that must mean that they're not like that, you know, other creatures aren't that intelligent either. Okay, now let's look at another video. This is the broken wing display of the plover bird. And again, I don't think that there's sound that's relevant, but did that look like the bird had a broken wing? It does not. The birds are doing this every time a predator gets close to its nest, and they go far away from the nest, and they pretend to be broken, to have a broken wing, to flap around to grab it, get its attention. It's kind of a really cool behavior. Let's see, what else? This is, wow, okay.
Great height onto a hard road does sometimes crack it, but some nuts are particularly tough. So the crows have devised a better way. Drop it among the traffic. The problem now is collecting the bits without getting run over. So some birds have refined their technique. They station themselves beside pedestrian crossings. Wait for the lights to stop the traffic. Then collect your cracked nut in safety.
Is that crazy? Like being able to use human artifacts again, like for their food. Okay, so that the piping plover example of the broken wing, a lot of people find that one to be interesting, and then the question is the bird actually knowing what it's doing, or is it just instinct? And so the evidence is like, oh, it always moves away from the nest. Okay, that's interesting. And it tends to move more when the creature isn't paying attention to it than when it is. Okay, that's interesting. It could still be not that intelligent, but it seems like it might have some ideas of whatever predator's intelligence is going on, or whatever the predator is looking at, so it's paying attention. This is not about other creatures' minds, but it's about cause and effect, right? So it seems like these crows have figured out a cause and effect relationship in a really complex way. It's a little, I mean, we'll talk, if anybody can come up with like a super skeptical approach to this, because like the non-skeptical approach is super easy. It's like, oh, they're just smart. But like, this is Amanda's superpower. If you can become, you can give me the most skeptical interpretation of how they're not that intelligent at all. Yeah, we'll keep going. There's more videos, but as we go, you know, try to think of a way to show that they're not actually that intelligent and yet could produce the same behavior. Keeping in mind that this behavior is not just like dropping the nut, but waiting and then going to the special spot where cars stop and waiting and crossing to pick up the residue. So there's a lot, it's a really complex behavior. We'll try to figure out how intelligent you have to be to do that. Okay. Actually, let me do the other crow before I do Alex.
To see if the crow can act out a 3-step plan, I think like 3 chess moves into the future, and pull up the string to get the short tool, take the short tool to get the long tool, and then take the long tool to get the food. Oh, this should be really, I'm really fascinated by this. I really want to see if they're able to do it, because
oh, sorry.
Hope they can, but it may just be too long a distance between their first action with the string and the time they're getting the food, so they're going to kind of forget what they're doing once they're up and string pulling. So yeah, I'm really curious to see how this is going to go.
This is the first time this experiment has ever been attempted, and our cameras are there to record what happens.
The crows have done amazingly well and really surprisingly well. We didn't expect them to be this good at these kind of problems. First we put the...
So that one is not just tool use, but it's being able to infer ahead of time the tools that you could use, and then using a tool to get another tool, like it's an abstract entity, to get another abstract thing to get the goal that you want, right? So there's an intermediary amount of reasoning. You have to like reason ahead. You can come up with super skeptical ways, like, you know, let me know. That'd be awesome. Let's talk about Alex.
Alex, what matter? Whoa, that's right. How many? 2. That's right. You're a good boy. No, sweetie. No, you can't go back yet. You gotta want some water. All right. Do you want some water, or are you just asking to interrupt? You just asked me to interrupt. I know. I know. Okay. What color bigger? What color bigger? Green. Oh, you're a good boy. Okay, Alex, look. Well, look what I got for you. Hey, look. Look at all these neat toys. Look. Hey, look, can you tell me on the tray how many green block? Green block. Good parrot. 2 green block. 2. Good parrot. One of the things Alex doesn't have is a knee-jerk response to the types of objects that you present him. He can look at 2 objects and answer several different types of questions about those objects, or he can look at a novel collection of items and answer questions about that collection. What this shows us is that he really understands what those questions mean.
There's so many like awesome examples of Alec. This sadly passed away a couple of years ago, but it's an awesome example of a parrot that seems like they can understand concepts, can understand abstract units, can count, can like recognize multiple traits of objects and like vocalize the issues. So that one's awesome. Oh, I love Alex. Okay, let's look at some elephants.
Just want to get to the point too quickly.
Now, what are they making noise about right now?
That's the Penelope family, and it's their way of saying hello.
Andrea knows it's the Penelope family because she named them and nearly 1,000 other elephants. She also recognizes them by their voices. Voices researchers are trying to translate into what could someday become an elephant dictionary. I find this elephant dictionary you're compiling exceedingly fascinating. I mean, how large a dictionary will it be?
We don't know. We have to really know a lot more about the behavior of these animals to sort of sort out these different vocalizations and what they mean.
Andrea's expertise brought her to the attention of Cornell University. Peter Regg, a behavioral biologist from Cornell, says the dictionary is still in its early stages.
We're in kindergarten. We're just learning the very first few words. And Andrea is going to help us put those words together.
So that's one part of the elephant one. I also wanted to show the elephant graveyard.
On the other side, something unexpected, an elephant corpse. Elephant graveyards may be a myth, but death holds a strange fascination for them. The hovering foot seems to be trying to deduce who this was. A lost family member, perhaps. The trunk seeks clues from the smell. It's as though they're paying homage to someone they once knew. Some scientists believe elephants can grieve. Their actions certainly suggest they're deeply moved by what they find.
So elephants are really cool. Well, they're just generally really cool. But it seems like they can, they're social creatures. They can communicate and communicate emotions. There's evidence that they, well, you just saw them pausing around dead corpses of dead bones of previous elephants. Some people think maybe it might just be the smell or something. But then Asian elephants, not necessarily African elephants yet, although you know, it's hard to do these studies, can identify themselves in a mirror, which is kind of cool. It's one of the tests that we use to figure out how intelligent animals are, which I'll talk about in a little bit. Oh, this one. Try to see how you would do. Like, look at the prompt and see how you would do. It's just counting. all. Embarrassing. Oh, and then they have a human, yeah. So a short-term memory is way higher in chimpanzees, like way higher. And I don't know, I mean, if you can come up with a skeptical reading of that, it's hard to come up with one, but I'm open to it. I mean, sure, maybe, I don't know, who knows? Okay. Let's get to some language stuff.
She's holding Kanzi's 3-month-old son, Tico. She's taught the bonobos to communicate with symbols called lexicograms.
So how does this lexigram thing work?
We talk to Kanzi with this.
Kanzi, come here. Come here. Can you say matata?
Matata.
Matata. Matata is Kanzi's mother. All I have to say is the word, and Kanzi can find it. Can you show me Bob?
Ball.
Oh, that's right. Show me egg. Egg.
Egg.
Egg. That's right. Show me chow. Chow.
Chow.
That's right.
Dr. Sue, how many words does Kanzi know?
We just guess he knows several thousand. On his keyboard, there are about 450 that he can understand. The number that he uses on a daily basis is maybe 30 or 40.
How did you teach Kanzi these words?
The same way that I did with my son. I just talked to Kanzi like you see me talking now. He just was around me and learned it like a child. So I can say to him, Kanzi, would you sit up? Please sit up. Okay.
Dr. Sue says Kanzi and the other bonobos in her care are the only animals in the world who can do this.
Go show her what you can do with a balloon. The important thing is that humans are said to be the only species that has control of their own breath. But Kanzi obviously has control of his breath.
So language is one of the big ones that's fascinating. And we've tried to teach various primates how to speak. And in the 1930s and 40s, they just failed again and again because they just don't have the vocal tract to do it. So that's when we started we started using sign language to try to communicate with some of these great apes. One of the more famous of which is named Coco.
Who is that?
Passing the mirror test.
It's me there. Okay, that is you. Gorilla, animal, Coco love. Okay, that's very good. That is you. You are a lovely animal.
When Penny Patterson and Coco, a western lowland gorilla, met nearly 30 years ago, neither had any idea they would become friends for life. In the long history of human-animal relationships, their story is one of the most fascinating. It is the true tale of a young woman and a gentle giant walking hand in hand into a whole new world of understanding. They couldn't have known that their intimate friendship would shatter century-old stereotypes and change forever our outlook of both gorillas and ourselves. Penny describes her friend with gentle honesty and affection.
Coco's about 5 feet tall. She weighs roughly 300 pounds. A little heavy for a female. The average is 250. She's a big female gorilla. Coco has a very strong sense of self. She feels she's important. She's got a strong ego. She's playful, can be very silly. A quick spin, a really quick spin, and then once you're good and dizzy,
Send you off.
She's got a good sense of humor.
Oh no! A monster! A monster coming to get the alligator!
She can be very stubborn, very willful.
Finish. You are not finished. You are not. You are not finished. You didn't do the work I asked. Please pick those up. Coco, you are very good at that. Please.
Their relationship is like no other. Penny and Coco are the first human and gorilla to share a common language. Penny taught Coco to speak sign language.
Play with them after you help. Okay?
So Coco became very close with Robin Williams some time ago.
Coco has been really somber and low-key. She's needing a lot of support. The sign that she told me was a cry, lip meaning cry woman.
Head bowed, lip quivering, Coco shares her grief with her lifelong trainer, Dr. Penny Patterson. I talked to Patterson at her home, not far from the Northern California Gorilla Foundation where she works. 43-year-old Coco is extraordinary. She can communicate. And in 2001, her meeting with Robin was life-changing.
Coco understands spoken English and uses over 1,000 signs to share her feelings and thoughts about daily events. Life, love, even death.
She's aware who it was. There's only one Robin ever been in our life.
She's the only Robin she knew.
Her memory is strong.
Like most people who meet Robin, Coco was smitten from the moment they laid eyes on each other, and they played like a father and child.
What happened when Robin visited is that Coco was actually in mourning for her lifetime companion, Michael, and it was Robin who brought her out of it. The first time she smiled since Michael passed was when Robin and her met.
She took his wallet, looked at his face on a box for his video, and finally stole his sunglasses.
She had my sunglasses on. Turned away, and then she looked out the window, and she looked crazy. They actually looked very nice.
Of course, Robin found humor in everything and worked the encounter into his act.
There is only one animal who can tell you if she is happy and wants to mate. That is Coco, the silverback gorilla. When she saw me, the blue-eyed simian, she was intrigued. But she must have sensed something because she grabs me by the hand, starts to take me in the back, and it's like Doctor meets Deliverance. And I'm expecting the crocodile hunter to walk out and go, "Oh, Friday!"
How will you remember Robin? I was in awe of him as a person, and especially as he related to Coco.
So let me stop this. What do you all think?
It seems kind of foolish to just assume that because something doesn't have the vocal cords, it's what the F gene, I think it's called, or something like that, to be able to talk like us doesn't mean that they can't have intelligence of their own. It's foolish. Like, dogs have not been shown in studies to be able to push buttons that show, like, I want to go play or things like that. So, I don't know. I think we were really foolish when we first started looking at intelligence and assuming only humans had this giant expanse for it.
I mean, I think I agree with this because I do include it in this section of the class just because I find there's a lot of continuity with what we think of as special to humans and what we can observe in non-human animals. That said, there's a lot of people that disagree with me, and so, you know, like if anybody wants to like give the super skeptical side, I'd love to hear it. Nobody's super skeptical? It's okay. You don't have to be. Okay. So let me share this. Oh, sorry, Chris? So the videos for this week, we're just basically talking about all of the evidence that we have of animal cognition and what we think that they can do.
I mean, there's lots of really cool examples, but a lot of it is us having to infer what's going on, because they cannot, aside from like Coco, they can't speak to us and tell us. And so a lot of the research, like the stuff that I talked about in the lectures, span 750 million years removed from us, right? So the way to read this is a family tree in biology. They're called phylogenies. Humans and chimpanzees are 6 million years apart. That means that 6 million years ago, there was a common ancestor between humans and chimpanzees. Gorillas and humans also shared a common ancestor, but that was 13 million years ago. Same for gorillas and chimpanzees. Okay. Capuchin monkeys shared an ancestor with humans 25 million years ago, but also with chimpanzees and also with gorillas. And then you keep going down, and it's 95 million years ago before we're related to horses, cows, and killer whales. And then 160 million years ago to elephants, and basically at the beginning of the dinosaur era, when birds and parrots are related to us. That's when we last shared an ancestor. Octopi, actually, plural should be like octopodes or octopodes or something, whatever. Our ancestor with them is very, very ancient. It's before bilateral symmetry, so it's ancient. And the cool stuff is that, like, octopoda can they can read, well, they can't read minds, but they can like interpret intentions. They can plan ahead. They can do a lot of these really complex behaviors. And so there's really 3 basic options. You either discount the evidence that they can do that, right? You say that the common ancestor of humans and octopuses could do whatever complex behavior they could do, right? So like 750 million years ago, that ancestor could reason, let's say. Or you think that it evolved multiple times, right? The evolving multiple times isn't really that big of an issue. Like, they also have camera type eyes. They have 2 eyes that can look forward, but those evolved separately from human eyes. In fact, our types of eyes have evolved 6 separate times in evolutionary history. I don't know. It's one of those weird instances. One of the cool things about, sorry, go back. One of the cool things about thinking about octopuses, thinking about the plover bird. You remember the plover bird being the one with the broken wing, or the pretend broken wing, is trying to figure out whether they're behaving that way because they mean to do that or because it's like programmed into their genes somehow. We call it intentionality. Intentionality just means that it's something that arises from the animal's will as opposed to like a reflex or something, right? And so 0th order intentionality is when you like trip and fall. You did not intend to trip and fall, right? You fell and you're like, oh no, that was not intentional. 1st order is you decide to get up and go get a beer or go do something. 2nd order is when you're trying to fool somebody else. And then any order past that is trying to like if you're trying to fool me that you've done all of the reading, so then you like mention things that you think could be in the reading. But if you try to fool me into thinking that there's nth order. So if I have like beliefs about your beliefs, then you trying to manipulate my beliefs about your beliefs would be 3rd order, and so on and so forth. You can just like stack these up forever. So
when we talk about animal cognition, there's these really two radical approaches. There's the against anthropomorphism approach, which is sometimes called Morgan's canon. It basically is interpret the animal as unintelligent as possible, so as low order intentionality as possible. And the opposite is another view sometimes called Morgan's Rider, which is basically what Bailey was arguing for, right? That there's nothing really wrong with thinking that animals might have some of the same kinds of intelligences that we have. And so this push and pull, I think there's evidence on both sides, but in different aspects. And it depends on your own perspective of how animals, non-human animals, how complex they can be. One of the bits of evidence against thinking that animals are too intelligent, that's why I started off with a cellular slime mold, right? It's a single-celled creature that can find its way around a maze. That sounds like an intelligent behavior, but it's kind of not. It's kind of just trial and error, right? There's another example that's very, very famous. It's that of Clever Hans, which was a horse that was alleged to be able to add, subtract, multiply, divide, tell the dates and time, differentiate musical tones, read and spell and understand German. And it was toured around the world. And scientists for a long time couldn't figure out what was going on. They thought that maybe he was actually just super smart. And then one scientist in particular decided to try to do as many separate studies, isolating as many variables as possible. And he found out that this horse, Clever Hans, could not, the way he answers was by tapping his hoof. So if you would say 2 + 2 is 4, he'd be like 1, 2, 3, 4, tap his hoof 4 times and then stop. If you did that with like 3 × 2, he would do it 6 times and then stop. And you could come up with ways of asking him these things, and then he would do it. One scientist figured out that when the person asking him the question didn't know the answer, Clever Hans also didn't know the answer. And so what was going on, we eventually discovered, was that Clever Hans was just paying attention to the subtle body language of the person asking him questions. So when you're asking a question, you're more tense because you're expecting a response. And then once you get to the right answer, the people would like lean back, or would like their shoulders would get less tense or whatever. And Clever Hans was just really, really good at picking up on that. A lot of people hear this and they're like, well, doesn't this just show that Clever Hans was intelligent in a different way? And yeah, it does. But it also means that we might be misinterpreting some evidence of one kind of intelligence for another kind of intelligence. That's where skepticism comes in. Animals do lots of really cool stuff. I showed you a bunch of those examples. The last of which I mentioned was the mirror test. This one's really popular. It seems like animals that are like us can look in a mirror and recognize themselves. So you put a dot on their forehead when they're passed out. And if they're wandering around and they see themselves in a mirror, if they recognize that it is themselves, they will reach for their own forehead. Otherwise, they might reach for the mirror. Most great apes pass this. Dolphins do. Oh, I didn't show the video of the dolphin. Whatever. It's so cute. Birds, some elephants, not all. Dogs don't pass it. A lot of birds don't pass it, and non-great apes, monkeys don't pass it. But the question is, like,
and Franz de Waal has asked this a couple of times. He's a famous scientist that works with animal cognition. He says, a lot of these creatures are not visual creatures. So seeing a dot on a forehead, that's not even how they interact with creatures. They interact usually by smell. So if you could figure out a mirror test for a dog where like there was a reflection of its odor, would it like check itself? I don't know. It's tricky. It's tricky to even come up with a mirror test like that. Okay, and then the last bit before we stop on this is the idea of language. So I showed a couple of examples of Kanzi and Coco communicating. There's other creatures that can seem to interpret other signals that creatures do, right? Like they can interpret behaviors. The plover bird seems to be able to mimic having a broken wing in order to get foxes away from their nest. And so then the question is, are they just interpreting? So, okay. An informative signal is just something that you communicate without intending to. A communicative signal is where you're trying to get some information into another person's mind on purpose. Language is the best example of just communicative signals, because it's not an accident that I'm saying the words that I'm saying. I'm trying to get you to understand something, right? If I show up and I behave a certain way, you're like, oh, he must be, I've never showed up to class drunk. But I don't know. In my youth, I did show up after a night of drinking, and that was not a thing I will ever repeat again. Fuck, that's terrible. But like you might interpret something like that. Like that would be a signal that I did not intend to communicate. And so there's lots and lots of examples of these great apes, aside from Coco, who were able to use lots of human signs and communicate. And sometimes they would combine them in ways that they were not taught to communicate new ideas, which I think a lot of people thought of as evidence that they understood complex concepts. Anyway, I'm going to stop there. I went on too long with the videos again. So maybe we'll just ask the question about Morgan's canon versus Morgan's writer, which was the question that I asked at the end of the videos. Should we think that there is any aspect of human cognition, and that's broadly construed, anything that we do with our minds, that is not in some way continuous with animal cognition? Is there anything special about us?
I feel like language is special in the way that it allows you to like compound information. And like it provides like an organizational format for learning new things.
Yeah. I mean, we all know hundreds of thousands of words, right? And the best great apes could only speak several hundred or maybe 1,000. So maybe that's a good one.
It doesn't seem like they have the innateness with like grammar and stuff that we seem to have. So that's another difference.
Yeah. We seem to be able to figure out how to structure sentences and pick, we like absorb language as a default. Yeah.
It's kind of like how sometimes like your dog can make a specific sound and you know what they're feeling, but you understand it through your own lens. So it's like you don't start thinking about things in terms of like dog sounds, you know? And that's like how animals would be approaching our language.
Nice. That's a good analogy. Christopher?
I don't know, like that I mean, having a class on thinking, about thinking. I mean, animals don't do anything like that, or the weirder math, imaginary numbers, you know, any of the goofy math. I mean,
They don't have those classes because they don't qualify for financial aid. So. Math is a good one. Let's think about math for a bit. They can count. I don't know any strong, like they can determine bigger and smaller quantities. We have good evidence of that. They can't do like derivatives. Claudina, do you want to say something?
I was gonna say maybe like sense of danger. I always see the videos of like people feeding their pet snakes, like live mice and stuff, and the mice will literally like get right in the mouth of the snake. And it's like, we were so close. Yeah. I would have been trying to go in the opposite direction.
That is true. I mean, although we also have a very particular sense of danger, right? Like we're not afraid of, I don't know, cholesterol, even though it kills a lot of us, right?
Valid point. Valid point.
And also, I think it is pretty common for people to like freeze up in times of like intense trauma. And the problem with that is usually we train people who we put into life-threatening situations to not lock down, but you can't really train a mouse to like fight against a snake, you know?
I did have a friend lose a python to his mouse though. The mouse killed the python.
How?
He bit its head. He bit its head off. Attacked it, and because he bought another python, and he always knocked the mouse out from that point on because he threw the live mouse in there. I mean, or maybe rat, I don't know, but yeah. Because I asked him why he knocked. You know, I said, "Did you ever feed him? Do you ever feed him live ones?" He said, "I used to, but I lost a snake from it." True story.
I mean, there are spiders that hunt birds, so I believe it.
Isn't that kind of like
Bailey? Yeah.
Like while animals know they have like claws and fangs, they don't have the innate drive. Even like gorillas, like they don't have the drive for weapons. Like even though they have their strength, they don't have like most will lose in a fight against a tiger. But if you were to give them like a spear or something sharp, they don't use it. They don't want to use it, and they don't want to evolve it. Like their sense of weapons are like rocks and whatnot, but they don't seem to have the drive to develop it. So maybe they just evolutionarily haven't gotten there yet. But it seems like our drive to like continually advance our weaponry is a sense of like awareness and self, like, yeah, we're really weak and we're screwed otherwise. Like most animals don't seem to have that like self-awareness of just where the line ends for like our abilities.
I like that one. Like it's not the tool use. We see tool use everywhere. It's like, no, tool use for violence.
Yeah.
Right
Yeah, no,
to
like,
bear arms.
Yeah, like they might pick up a rock, but like half the time, like if they're in a fight against each other, it's fist, fang, or claw. Like there's a good sized rock like grill that you could pick up and just bash the dude's head in, and it's done. But you're not gonna use it. Like they don't have that like, I don't know, really weird sense of violence humans have. Don't know how you would phrase that, but yeah.
It's an interesting one. Huh. Claudina or Alyssa, I think one of you had a...
I was
Alyssa?
going to say a similar thing, but mine was just, it was more about like, we kind of do things we don't need to do. Like, why did we start doing philosophy? That didn't need to happen. And animals can do these like, animals can do these cognition things, but they don't feel a need to. They don't feel a need to try these things. Like they lack drive that we have in a lot of different ways. Like they don't have a need to make their life harder in the way we do. I think violence is a good way to explain that, because no other animal just kills other species of their kind for strange reasons, especially since we have like
Orcas.
reason and logic. It makes even less sense.
I think orcas are the only exception we
Orcas
have.
do?
Orcas are psychotic. They play with their food. They only eat certain things out of other animals because it's tastier or it gives them more pleasure because the animal fights and like dies slowly. Orcas are weird. They're awful beings. They're awful. And they eat themselves too. So yeah.
I have a friend who has an orca tattoo because it's their favorite animal. And I'm like, I actually have like a video of orcas like conspiring to kill seals just for the fun of it. And
Yeah, they like the noises they make as they die. Like the study showed it. It's weird. Orcas are like the most human out of like all creatures. They're scary. I love orcas. That's why I know them, and like dolphins are just as messed up too, though. Dolphins are awful.
dolphins do some really bad stuff, guys. Really bad stuff. Maverick?
Oh yeah, I was gonna just continue off Alyssa and how like when you mentioned math, it's the same thing. They don't feel the need to like say we use math to make the world around us be understood in an easier way. Like, oh, we need to fly 10,000 or 5,000 miles. But a goose, say they don't know the exact number, but they know the distance and they judge it differently on how their need to survive judges like when they migrate, but they don't necessarily think of a number in that sense. Maybe they have it. Well, I don't think so, but they have a general sense of knowledge of the distance they need to fly, but they don't. But they don't explain it as like a mathematical concept as we would.
So
like in a plane.
That sounds right. But so somebody, maybe let me pose a question to you. Somebody once described the way we very quickly process a trajectory of a ball. Like let's say a batter hits a ball and it goes, you can see how they hit it and where it goes, where it's going to go. You can like look ahead. And that they argued that there was some like quick mental math that we're doing, even if it's not like explicit at all. We're just like naturally tuned to trajectories. But like dogs can do that too, right? Like you throw a ball and the dog can know where you're going to go. What do you think about cases like that? Or do you deny that we're doing math there?
Okay.
I guess that is math. I mean, maybe in a sense of numbers, but I mean,
okay.
I mean that is a good point. But if that's like, yeah, I don't know.
I don't think that's math. I mean, I think you can take that experience and apply math to it.
Yeah.
You know.
Okay.
I mean,
Well,
but I
the
don't
math
think
is kind of like why the thing works. Like I think animals for the most part can figure out how things work, but they don't try to find out the why like humans do. So
Okay.
like we try to calculate using like the math. That's how we know exactly what is happening to the ball if it's flying through the air, but the animals just figure out how it's working, not why it's working. It's like that.
right.
I don't think
it doesn't ever work the opposite. Like you can, like playing billiards. You know, bank shots are pretty easy to set up mathematically and to solve, but you know, to actually do the thing, even if you know the math, like doesn't go back and forth. You know,
like
in behavior analysis, this is distinguished as knowing how, which is just like nonverbal knowing, just knowing how to do a thing, like that raven dropping the nut and using cars to crack it open. And then there's knowing that, which is verbal behavior, which is what we're doing. That's knowing how to describe things and so forth. like in a behavior analytic viewpoint, like the thing that makes us unique is there's this theory called higher order verbal relations, which is this language account, which is basically that we are unique in that, aside from just responding to the objective features of stimuli, we can also respond to the relative features of them. This is called like relational frame theory. So as we can learn to respond to, you know, normal operant conditioning, but also like something being bigger or smaller, or being here or there, things like that, which is probably why we're able to do this. That's where philosophy and all this other really abstract stuff comes from.
And
At least in
non-human animals can't do that? They can't.
Some I've heard that some behavior analysts argue that it's possible, but there's still like heavy debate. But I think that's a minority position. The generally accepted position is that that is unique to humans. So
interesting. Jackson, you were gonna say something before, or Alyssa? Okay.
I was just gonna say,
Sure.
I wonder if the reason it seems like they can't really do those things is because they don't want to and they don't see a need to, and it's kind of hard through like the tests they do in the learning language to get the animals to understand the concept of like why behind the how. Maybe we're just not testing them in a way that makes them understand that the point isn't how, it's why.
Like cats, right? Cats are super smart. They just don't care about anything you want to do.
Yeah.
In fact, the Clever Hans, the guy that trained Clever Hans, also tried to train a cat and a bear, and the cat just would not pay attention, and the bear was a bear.
Doesn't that prove a cat's intelligence? Like, if we could really make them do some of these tests, we'd be like horrified. Like, some studies show like they plot your death at night when you're not paying attention. Like, some cats literally like plot how. It's like, what? We domesticated this like animal, you could, you know, because like it'll keep the pests away, and it's like just trying to plot revenge. It's like we could do these tests on these cats, we probably wouldn't want to. So it's probably why we don't.
It's fair.
Cats will eat your dead body too.
Yeah, they're horrified. Cats.
Cats crave violence on the inside. If they could produce the violence they want, I think.
The whole like mother, I crave violence thing is literally just all cats are, and it's probably why we don't do intelligence exam. Like they know if we know it's done. That's why they don't do it.
They would be too powerful.
That's literally my psychology class was talking about this, and this is what we came down to. Is they're deliberately not doing it.
So we've decided that this class is pro-orca, anti-cat.
No, I love my cat. My cat is adorable, and he loves people.
All right. All right.
All cats except mine.
Hashtag not all cats. Okay. Awesome. Okay. Any other thoughts or comments or questions before we leave animals behind, or non-human animals? Sorry.
We didn't see, like, do animals display language in their own habitat? Like, I know we can teach them language, but do we know a lot about how they interact with each other just in a uncontrolled environment?
So we know that they can teach songs to each other. This happens with whales. This happens with birds. This happens. So they can teach, like, it is a cultural transmission of music. We also know that dolphins have names, which is kind of cool. You can actually call dolphins by their name. It's like a chirpy particular sequence, and they can like identify each other based on their names. A lot of this gets really hard to distinguish between informative and communicative signals, right? Like, we know that there is stuff that they are doing and that they are interpreting each other, but do we know that they are intending to communicate?
Well, my thing is that like maybe they can learn complex language, but the fact that they don't do it unless we teach them it is like, does their intelligence come from them, or are we like helping further their intelligence?
So there are chimpanzees that have trained other chimpanzees to speak in sign language. Alex was the parrot was around when they were trying to teach another parrot how to identify objects, and he just called the other parrot a dum-dum, just like kept like insulting him.
Why don't we use parrots more often? Why is there only the one Alex the parrot?
I don't know. It's got to be a cultural reason. It's the same reason we don't use dolphins that often, and that's because there was some weird sex stuff in the past. But you know, you can Google that on your own.
Okay.
Don't Google it though. Do not Google Peter the dolphin.
Right.
I'm not going to.
Is there a correlation with what we're talking about? Have you read the nuclear protest book, The 100th Monkeys Syndromes? Have you ever read that?
I have not, no.
Yeah, well, let's check it out. I got it through doing anti-nuke stuff in the 90s, but this was like, they studied two groups of monkeys, or they were studying two groups of monkeys, physically separated, like island and mainland, and no transmission, like, and they couldn't hear each other. And the monkeys on the island, one or the other, learned a skill. And at one point, you know, there were more and more of the monkeys on the one area learned more and more of the skill. And then at one point, they just say it's the 100th monkey. They don't know if it was on whatever number it was. All the monkeys on both sides could do it, learned the thing.
It's like a network effect, right? Like the very first couple of things don't, maybe like they spread from one to the other, and then boom, all of a sudden it's everywhere. It's
yeah.
And
you know, of course, they were trying to correlate it that if we could all teach each other the new thing, that eventually would be a no-brainer. I don't know. Maybe that's more of a metaphysical thing.
What was this?
It was a tool, using a tool. I forget which. I read it like literally 20-something years ago, but it's a short book if anyone wants to check it out. But yeah, it was just. But then all of a sudden, on both sides, the whole population started doing.
Yeah, it's one of those. It might be like trying to understand exponential growth, right? Because like 1 teaches 2, 2 teach 4. And it's really hard to understand. Like there's the common example of like you have a pond, there's an algae that doubles every day, and at the end of 2 months, it's going to cover the entire pond.
Right,
On
so
what
one
day?
penny doubled is $1 million after a month, you know?
Oh, it's way more. Yeah.
Yeah,
but
it's crazy.
So here's the question: like, at what point after it in the 2-month period is half the pond covered by the algae?
I don't know. It's like 30 seconds before the end. I don't know.
Second to last day.
Yeah, because it doubles the next day, right? So it's 50% on the second to last day. At what point is only 1% of the pond covered?
The day after 0.5%.
That's true.
Think like 9th to the last day or 10th,
something like that. Yeah.
Yeah.
So for 40, like for 50 days out of 60, if you would look at the pond, you would see nothing, and then the 100th monkey effect takes over.
Right.
And all of a sudden it's everywhere. It's kind of like why we're having so much trouble with COVID-19, right? Like nobody knows anybody that's sick until you know everybody that's sick.
Right.
Yeah. So we're not good at thinking this way. But so it goes. That's cool. Yeah. I don't know, maybe if we taught enough chimpanzees sign language, we could eventually get a Planet of the Apes type scenario. That'd be kind of cool. Alyssa, did you have a question? Were you raising your hand? No? Okay. Any other thoughts before I let you all go? That's fun. I think next week we finally get to emotions. We've been talking about emotions for so long. No, next week is embodiment. Sorry, the week after that's emotions.
I'm like Charlie Brown with a football. Goosey with a football with emotions. Okay, embodiment follows from animal cognition, and then emotions follow from embodiment. There's a trajectory. You can see it in your head if you think about it, because you have those human brains. Have a great week, y'all. Bye.
Bye, Carlos.
Bye.